And then I'm gonna share my screen over. All right, so we're gonna be doing 9.2 today, but I needed to show y'all at the very end of 9.1, they were having y'all put stuff in interval notation. Walker. Say Walker. Walker.
Taylor.
Walker Taylor. Let me care about me. All right, so let's go. This is 9.1 interval notation. This is actually called composition of functions for this section, I guess you would say. But I needed to show y'all interval notation because up until now, all we learned was what we call circular notation, where you put X and then they take that line that means such thing, and then you put X is a real number and X couldn't equal 5 or something. So interval notation, so to represent all real numbers, whoops, we use, now y'all heard of infinities and negative infinities? Negative infinity goes negative as far as I go, positive infinity to the right. In interval notation, to represent all real numbers, we actually use those infinities. So I use curvy parentheses, and I go from negative infinity to positive infinity. Now, I don't know if y'all ever messed with number lines where you had to color in the dots or leave them hollow. Well, that's what these parentheses are almost like the hollow dots. And then if you ever use brackets, that's like the solid dots. So all real numbers, and they always use curvy parentheses because you can always subtract one and get further and further. So there's not an ending point on those infinities, okay? They keep going forever. Okay. So if your answer says there's no fractions or no radicals like we're talking about, then your answer will be all real numbers from negative infinity to infinity. So all functions start out with this domain, and then when you work the problems, you try to figure out what's being excluded, okay? So to exclude a number, from the domain, we use what I call a union. Last name. Okay. Now this little union means and. Okay. Now there's another thing we need to figure out on these. If you are equal then we will use brackets. So if it's equal to that number, we'll use brackets. Otherwise, use the parentheses. So if it cannot equal that number, I'm going to use the curvy parentheses. Okay? So they're sort of like the hollow dots, and then the brackets would be like the solid dots when y'all use those. So if we want to exclude a number, we're going to call it A. We would write interval as, so I'm skipping me a number now, okay? So we're still going to start out here at negative infinity on this one. But we go up until we hit that letter A, or that number. And I'm going to union around this. So this means my interval can come from negative infinity until I get to the A. But remember, since I got the curvy parentheses, it can't equal the A. So we sort of union around that A, it comes out of the domain. But then from A, I can head off towards positive infinity. So y'all with me on this? Any numbers I'm going to exclude, I'm going to use this union. I can go through that number, can't equal that number, that's why we're using the curves. But then you can pick up right on the other side of that number and start headed off towards infinity. The only thing you're worried about is that one number there, okay? With radicals, what's a radical at the end? With radicals, remember, under the radical can be equal to or greater than 0, right? So on a radical, I've got a square root of A sitting under there, right? And I know that this A has to be greater than or equal to 0. And if I get a negative number under my radical, take the square root, I'm going to get imaginary numbers out of that, okay? So it's got to be greater than or equal to 0. So to write this domain, the smallest number it can be is the 0, right? Now notice I put a bracket on that because it can equal 0. So that's the difference in the brackets and the parentheses. This one says you can equal 0 with the bracket. These curvy parentheses mean you cannot equal that number, okay? And then this would head off towards infinity. So your radicals are going to start at a number and head one way or the other. Your fractions are going to go from negative infinity to infinity, and you're going to exclude certain numbers, okay? So let me work one of those toward the end and actually do the interval notation with them to show y'all. Well, hell, I'll just make that one. So find the domain of, so I'm going to do one fraction one, and I'm going to do one as a radical, okay? So let's start out with f of x equals 6 divided by x plus 5. There's only one number I'm really worried about putting into that x that'll make that a 0 on the bottom. But officially, I would take this x plus 5 and set it not equal to 0, and then solve that for my number, right? And on this one, I'm only going to get one number. I'm going to solve this, and it's telling me that x cannot equal a negative 5. But any other real number works, right? So for this domain, we're going to start out here at negative infinity to the negative 5, because I'm cruising through, all my numbers are working, and then boom, I hit negative 5. That's going to make it undefined. So I'm going to union around that negative 5 with the parentheses, because remember, it don't equal if I use parentheses. And then this means and. So you got this part up to negative 5, but then you got the part after that negative 5. So that parentheses is really telling me, hey, this could be starting at negative 4.99 now and cruising on, okay? Until I hit infinity. Okay, so anything fractional, your domain will look like that, okay? Now, When we start solving quadratic type equations with the x squareds, and we get two x values, we'll have two unions on those, okay? And that won't start till material for that second test. Now let's do this with a radical. On under here, I'm just going to do x plus 1. Now, what I need is my domain to contain all numbers that keep that from being negative under that radical. All right, my thing? Weeks. Okay. That's what I'm thinking. I'm getting closer. Oh, you did good. Same seat. Okay. Same seat you had Monday. All right, so this will be the difference. This is where you'll see this happening, okay? Because I know that the x plus 1 under a radical has to be greater than or equal to 0. So this can equal 0. Take the square root and get a 0, okay? So I want to solve that by what? Subtracting 1. And I get x has to be greater than or equal to a negative 1. So the smallest number I can be is that negative 1, right? So I'm going to start my domain at negative 1, but this time I'm going to use a bracket. The negative 1 is possible number for it, okay? And then I always look at these little inequalities. It's pointing right, so it's telling me I'm headed off to the right towards infinity. And then infinity always gets a curve, okay? So when they say put y'all's answers in interval notation, they want something like this, okay? And then remember, all real numbers is going to be negative infinity to positive infinity, okay? All right, so time for inverse functions. So this is what, 9.2. So we won't get deep into what are these inverse functions. I'll sort of tell you what they are, but we won't be worrying about graphing and all that. We just want to be able to find those inverse functions. But inverse functions are like exponential graphs, like x squared and stuff like that, versus what we call logarithmic graphs, which come down. And we'll learn about logs later in life. They come in chapter 9.3 and stuff, but when they switched it around, they wanted all the equations up front, so they put these 9.1 and 9.2 up front. X squared graphs and square root graphs. One will curve up, one will curve down. But they're inverses of each other, okay? Adding and subtracting are like inverses of each other. So first of all, we're going to find the inverse of a relation. You know, remember, a relation is just a set of ordered pairs. So if I have a set of ordered pairs, AB, CD, and EF. That's my relationship. I got my 3 points in here, A, B, C, D, and E, F. To find the inverse, we switch each ordered pair X and Y values. which means the inverse of the example I got up here, to switch the first coordinates, that become a
I
B.
just got one more question. I'm sorry to interrupt you, but did you say on 1.1 you was throwing that section out? Homework, I'm sorry. I just need to know.
So the one that got filled out, I removed it from the blackboard, was 2.1 support.
2.1 support. Okay. Thank you.
Because it had a lot of drafting in it, and we had so much drafting in 2.1, you call it down per section, so it was sort of like repetitive, you know. So, yeah, but everything else should be live in there. Okay. And it was shown in Blackboard, but it shouldn't have been shown in MathLab, I don't think. I don't think y'all would actually be able to get into the 2.1 support.
I can see the support. I can see the support.
Oh, could you, like, what is that actually good?
I haven't tried to actually do it.
Okay. So hopefully now, though. But y'all, all I'm gonna do is come in and go BA for my first one. All I'm doing is switching in, make some Y's around. This one will be a BC, and then this one will be a FE. So let me break out the example for that one, and then we'll get into what we really want is the functions. So this example, find the inverse of, and they're giving me my points, are going to be 4,2, -7, -1, -2, 9, and then 5, -5. So let me write my answer. Now remember, MathLab is going to give you this. They give you the fancy parentheses. But everything else you got to put in there. Make sure you're using commas to separate everything or it will mark those wrong, okay? So 4,2, when I find my inverse, becomes 2,4. -7, -1. So y'all with me, I'm just switching each one of these X and Y values in each one of my little points. So next, that's going to give me what, a 9, -2. And y'all finally, I'm going to switch that, get a -5, 5, okay? In MathLab, make sure you're using the parentheses. They got to have commas in between the numbers and in between the parentheses for each one of them points, okay?
Yeah, but they got me.
Huh?
I said, they got me.
Yeah, they're really picky on that, putting it into that MathLab. All righty, so we're going to look at functions, though. So we're going to find the inverse of a function. So the first thing, the function must be what we call one-to-one. Now, y'all remember last week I showed y'all the vertical line test to see if it was a function. I ran my vertical line across it, and if it hits the graph more than once, it wasn't a function. Which meant the x's can only have one choice for the y values. Well, to be one-to-one, we use a horizontal line test. And it still cannot intersect this line more than once. So what that means is each x value only has one y value. Each y value also only has one x value. So it's going one-to-one.
So if it goes to the line twice, then it's not a function, or the function isn't one-to-one.
So if I had to say, even my parabolas, remember my parabolas we've been playing with? That parabola would fail the horizontal line test. So what they do in cases like that, they restrict the domains. Instead of going from negative infinity to infinity, they might say, well, we only want to look at this from, say, 0 to infinity. So if you only look at the right half, it would be 1 to 1. Because it'd only be that one side going up, okay? But yeah, we'll put that in a second. So we'll use vertical line test for that. So if it is 1 to 1, here comes the process that finds your inverse. First thing I do, I'm going to have something like f of x equals some function, right? First thing I'm going to do is I'm going to replace f of x. Oh, damn, that was good. With a y. Because remember, we can't solve them with that f of x in there. We need some kind of variable in there for it. So now, here's the part I get people at. You're going to have y equals something, something x over here. We're going to switch the x and the y around. So switch the x and y variable. Which means now you're going to have x equals something y on the other side, okay? So once I switch that x and the y, I'm then going to solve it for the y. So solve for the y. Now, since I'm finding the inverse function, I'm not going to replace the y with what we call f of x. I'm going to replace the y. So replace the y with f negative 1 of x. When you throw that little negative 1 right there, that now tells me that this is the inverse function. Okay, so this is inverse notation. So that's inverse notation, and then we're done. Now, MATLAB always puts the little f negative 1 of x equals, and you just got to punch in the actual answer you're getting, okay? So I'll look at a few graphs real quick, show you how to tell if they're 1 to 1, and then we'll do the functions. And let me tell you, I'm pretty sure that those last 1, 2, 3, 4, those last 4 for y'all are all going to be 1 to 1. We don't want to give you a problem and then they all be not 1 to 1, right? And y'all won't be able to find no functions at all, right? So here we go. So here we're going to use horizontal line test. To determine whether it's 1 to 1. All right, so this one was just showing mainly the top part of this graph. So they want to know if that's 1 to 1. Yes. Definitely yes, because if you run the little horizontal line along this, it's only going to intersect that once everywhere I go. So that is definitely a yes. Okay. let's see. So this one has a funny graph. It's got one side going down like that, and one side going down like that. So you run in your horizontal line. Uh-oh. It hits this side and this side, so we're going to put a no for that one. And see what's happening when I run my vertical, my horizontal line, I'm hitting there and there. So that means that whatever y value is running across that, it's got two choices for the x.
Right.
And we only need one choice for the next, okay? So y'all have, there's like 3 or 4 where you're just looking at the graph and running the vertical line, I mean, a horizontal line down it, okay? But here's what we want to get into. The actual algebra, right? For the following. Determine if 1 to 1, and then B, if 1 to 1, find the inverse. So I'm going to start at 6, these go 6, 7, 8, and 9. But let me tell y'all, they all got inverses on those problems, okay? The only one where you're going to get a no might be some of these pictures, okay? So I'm going to write this one starting at 6. F of x equals x minus 6. And I'll tell y'all one thing, that would be a straight line. X minus 6 is like y equals mx plus b type form of a line. All lines are definitely 1 to 1, okay?
See, I got on here x plus 6.
Oh yeah, then watch. You're going to notice that the inverses are almost like the original equations, other than maybe a few operations are different. So yes, so you can place that on your calculator and see that it was a line, and it is definitely 1 to 1. So we're going to find the inverse. So the first thing I said was to replace that f of x with a y. So we're going to replace the f of x with a y, so I get y equals x minus 6.
Is this right? Can you look at my calculator?
What now?
Did I put it? Can you look at it around this calculator?
You can, the graph.
You gonna do it? You gonna do the graph on? You gonna do it on the board?
Well, just put it on the calculator.
That's what I was saying. I did it. I'm trying to see.
So let me show you. You go y equals. Yeah, you're perfect. And then if you run that to the horizontal line down, you're perfect.
Wait, how I do that? Oh, Chicky, you told me I do it on.
Oh my God, my pencil for. All right, so I've got the y replacing the f of x. Then I said switch the x and the y around, right? So this will become x equals y minus 6. Switch that x and y. Now, solve that for the y. You got one loop. I want that y all by itself over there.
So for sure.
Add 6. So I'm going to add 6 to both sides. So I get an x plus 6 equals my y. But ain't that the same as y equals x plus 6?
Yeah.
So I'm just putting my y first is all. So here we solve for the y. But then the last step was to replace that y with the f negative 1 of x. So I'm going to come down and go f negative 1 of x equals x plus 6. So here replace y with f negative 1 of x. And remember, that's just symbolism now, but this now tells me that the inverse function is x plus 6. Yeah, that's what you said in the beginning, wasn't it? Mm-hmm. So you'll notice they're going to be really similar. If one's subtracted, one's probably got adding on it. If one's being multiplied, the other one's probably going to have division on it and so forth. Okay. All right, y'all, questions online? All right, I'm going to put that another one. The trickiest thing is how y'all solve some of these. So the straight lines, you just get the x by itself for the y and be done, okay? So let me up the algebra part. See how y'all do it with cubes.
Yep.
Okay. So let me try this one. This will be like number 8 for y'all. F of x equals x to the cube minus 8. Well, you should have that on there too.
I got minus 4.
What notes you got over there? What's in this kind of math class? In the past, huh?
Don't do that.
All right, y'all. So this is definitely 1-to-1. So this would be a graph that sort of comes up, crosses, and goes up. But it's always going up. It's not really flat. It looks like it's always going up. But they're all going to be 1-to-1, okay? So since it's 1-to-1, I'm going to replace the f of x with a y. So this becomes y equals x to the third minus 8. Next time, switch them around, right? So switch that x and a y so that you get x equals y to the third minus 8. So notice, although I switched the x and the y, I kept the exponent on the right side where it should be, okay? I'm not changing the exponents around, just the variables. So I need to solve that for that y now. So here's the trick. When you got cubes on those, you want everything on the other side and that y cube sitting there by itself first off. So to do that, we're going to add 8 to both sides. So this side gives me an x plus 8. That's going to equal my y to the third. So things like x squared, y cubes, y to the fourth. To undo those kind of exponents, we take roots. Square roots, cube roots, fourth roots, or whatever. You take the root that matches that exponent. Okay? So what I'm saying is, on that y to the third, I would be taking a cube root of that. Cube roots undo cubes, square roots undo x squared type stuff. But guess what? If I take a cube root of that side, I got to take a cube root of the other side. So this would be a cube root of x plus 8. So y'all remember, square roots, cube roots undo exponents, or exponents undo cube roots and square roots. They undo each other. Okay? So the cube root of a y cube equals a y. Oh Lord, can we do anything with that?
No.
No, so that's just going to say a cube root of x plus 8. So when you start out and you got cubes as your function, your inverse function better have cube roots on it. And then the last thing I need to do is replace the y with f negative 1 of x. then you're on the right side, still going to stay a cube root x plus 8. Now, I do think in MATLAB, when you put this kind of answer in, you got to grab the radical that's got the little box where that 3 is. And that lets you put in the different indexes for your radicals, okay? So just to see if y'all are with me, if this was a y to the 4th, I would have done what to both sides?
The same?
Same thing, but it would have had a 4 up in that notch, okay? Now, I will say this. Y'all remember the composition stuff I did the other day? The F of G, like fog and GOF. I will say, if you put these functions inside of that, replacing the X, you always end up with just the X as the final answer. But we don't have to do all that. I'll just let y'all know. I'm just giving y'all extra knowledge. All right, let's see what I got here. F of X equals a square root X minus 4. So if you graph that, you'll see it is a one-to-one graph. So I'm going to find my inverse, okay? Now, if you grab that, make sure you got that X minus 4 up under your radical. And let me see what you got going. Oh, okay, so clear that. Clear that. Now, second, X squared, that radical, it'll be your X, well, I think, minus 4. And right. So see, it sort of just slowly goes uphill, but it is sort of always going uphill on that, okay? All right, so I'm going to replace the f of x with a y. Then I'm going to switch them around so that I get x equals the square root y minus 4. Now, this is similar to this one. You'll notice over here I started out with the exponents and ended up with the radicals. This one I'm starting with the radicals, so I'm probably going to end up with the exponents. But y'all, here's the thing. I cannot add 4 at the moment because it's all up under that radical. I can't take stuff from under radicals and magically move them around. We got to get rid of that radical. So to get rid of a square root radical, I would take this right side and square it. When you square a radical, the radical disappears. And all that's going to be left is that y minus 4. But if we square that side, we got to come over here where the x is and square it. So at the moment, x squared is coming down, can't do nothing with it. But this exponent just now canceled out that radical, and all that's left is a y minus 4. But y'all, we got one more move to get that y there. I'm going to come in and add 4 to both sides. So this gives me what, an x squared plus 4. That side gives me my y. But look, now look at that. Look how similar to that is to this. I got something being hit with an exponent plus or minus a number. My answer here is something with an exponent plus or minus a number, okay? All right, so we solved for the y. Now we're going to replace the y with f inverse of x. And that'll equal what? X squared plus 4. Are you on homework? They should be really similar, right?
Yeah, it's pretty close.
Just a few numbers might be off of those.
Still the same concept.
So now I'll do the number 7 that I skipped sort of. I didn't know how much time we had. So this is the last of them. And this is pretty much a straight line. F of x equals 3x minus 3. 3x minus 3. So go back up. It would be the second one probably on yours.
Yeah.
Sort of similar. So we know it's another line, so it's going to have a 1-to-1. So it should go uphill a little bit to the right. So I'm going to replace the f of x with the y. So start out on these problems, replace the f of x with the y. Then switch them so that you get x equals 3y minus 3. Oh, yes, I know. Next week is the day you don't want to miss. We're going to be solving systems of equations. I don't know if y'all have ever done, y'all probably had messed with 2 equations at once where you add them or did substitution and all that.
Right here.
3.5 or something?
3.68. I don't know.
3.5 would be next, and hey, there's some long problems on that, I ain't gonna lie. So bring in calculators and get good programs next week, okay? Y'all ever heard of matrices? Where you solve them on the calculator? Okay, well, I'll be
I
fine.
forgot how to put them in here though.
All right, y'all,
Oh, you're 3.5, okay.
let me count on them more. Okay, problems in 3.5, but I start on one side of the board, work it all the way across, and then come back and start on it some more. All right, y'all, so solve that for the y. And notice since this one started out being subtraction, you'll notice the answer when you're done will be a little adding. And they're multiplying by that 3. You'll notice that when I'm done, I'll be dividing by that 3, okay? So here we go. First thing you do is add the 3. So x plus 3 equals 3y. And then now divide everybody by 3. So that's not definitely a y. Now, what y'all can't do is what people do in here sometimes. They come in here and say, oh, I'm going to cancel them 3s and make that a 1. But you cannot do that unless this x had a 3 in it also. When you got single fractions like that, if both of these on top can't divide by that 3, I wouldn't do it. Okay? The division distributes just like multiplication to everything. So I cannot do nothing to that side, so it's going to stay at x plus 3 over 3. And then the last thing we'll do is replace the y once again with the little f of -1. So that it equals to x plus 3 all over 3. Okay? These aren't bad. You just got to just follow them 4 steps. Replace that y, the f of x with the y, switch them, solve it, and then switch them back. Okay? And notice the similarities on these. X squared plus numbers end up being radicals. Radicals with numbers underneath end up being the squares or the cubes plus or minus them numbers. Okay? So y'all want a preview of what's coming up? Here we go. So I did that nice. So 3.5 preview. Just gonna show you what's coming up. Make you want to come. How about that? See, I'm just doing a two system equation, okay? So I'm going to do the two system equation. I'm going to solve by elimination. 6x plus 9y equals negative 24. 2x minus 9y equals negative 32. Now this is going to be easy. Easier than what I got coming up, okay? And really the reason it's easy is because I got something that I can eliminate right off the bat. But my goal is to try to add these equations together and if possible, eliminate one of them variables. I see one that I can eliminate right off the bat if I add them together. The 9y's and negative 9y's, right? If I add that, that'll give me 0. So I'm good to go. Now, next week, they might not be so easy to see. You might have to change the row by multiplying or doing some trick to get something that matches, okay? But on this one, I'm going to eliminate the y. So if I add these, 2 and 6 is what? 8x. That cancels. And on that side, if I add that, I get what? A negative 56. So I just added my two equations and the y's are gone. Can you now solve that one variable? Yeah. So I'll just come in here, divide both sides by 8. And I get what? X is a negative 7. So now I know what X is. So since I know what X is, I can back substitute into one of these. And now they both look about the same difficulty to me. So I'm going to take the first one, 6 times negative 7 plus 9y equals negative 24. So I know what 6 times negative 7 is. So let's see. That'll give me negative 42 plus 9y equals negative 24. All right, that's all that for the y. We're going to take 42 and add it. So 9y looks like 42 minus 24. About 18 or so. Well, y'all got a calculator. The big yellow one's in right there. All right, finish me out. Just divide both sides by 9. So the y equals 2. So when I write this answer, it'll look like an ordered pair. I'll put my x first and then my y value. Now, if you take this x and y and substitute into either equation, it will be a true statement. So does that bring back memories? Y'all done that before, maybe? Well, guess what? Next week, we're going to add x, y, and z's in these. So we eliminate one variable, then we got to come back and eliminate another variable. Then we get that answer, we back substitute into the one equation, and then we back substitute into the first one. So next week ain't the day to miss. But I gave you all a nice program that'll knock these out pretty quick too. So I always like y'all to learn them by hand first. So okay. Oh, if y'all want me over there, I'll go. All right, y'all online, any questions? All right, let me make sure I got Peyton. Let me see. See you later. All righty. All right, Owen got you. Let's see, Jacob. We got Jacob, Sydney, Brown. All right, y'all. So I'm gonna cancel this and get our